I picked this topic because when I was married, my husband and I grew mushrooms. And it was kind of hard, but once you learn how to do it, well, let me put it this way. I'll wait till I get to a certain point and then I'll tell you this little story. So it's astromycology, is the study of mushrooms and space exploration. And I knew mushrooms would go to space. I mean, they haven't really yet, but it just makes sense to me. Recently, NASA and several research groups from Ames have been studying how fungi can be leveraged to build extraterrestrial habitats and perhaps even terraform planets. Research, I have this stuff on my teeth because I was trying to be like rotten, like the mushroom stuff. And I ate and then I swallowed some of it.
You're gonna have to put this somewhere else.
Oh,
Let's try that.
okay. Is that better?
Good? I don't know. Did anybody hear you? All right.
Okay, research teams have constructed synthetic regolith, which mimics the components found on the surface of asteroids and Mars. And the definition of that is the layer of unconsolidated rocky material covering bedrock. And that is what it looks like. One species of mushroom that seems to fit the criteria is the oyster mushroom. When introduced to the regolith, its mycelium roots stretch far throughout the medium. The oyster mushroom can also break down the hydrocarbons and restructure them into sugars, which is an essential nutrient for most life forms. And that is the lovely oyster mushroom. Now, habitats. Another form of fungi called reishi was being used by a member of the research team for an unrelated project. After the mycelium had dried, he tried to crush the blocks to recycle them and found it to be impossible. However, he discovered the blocks could not only be sliced, they could retain heat. So they could pre-grow these into forms and use them on Mars to insulate you from the cold environment. Now, this is how my husband and I grew mushrooms. We used rice seed, and that white stuff is the mycelium. So we had a guest bedroom downstairs, and we had made shelves, and we had all these mason jars lined up for weeks. Nothing was happening, and we were watching TV, and all of a sudden we heard tink, 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 and all the lids were like popped off because all the mushrooms in each jar had just exploded. Like there was like hundreds of them, and then it just keeps growing and growing until that little what's in that jar gets like flat as a pancake, and it is hard as a rock. So I guess that could be used as a structure. And that's what the little slices of the reishi blocks look like. Now the mind. Some recent government studies have been conducted using psilocybin mushrooms to treat PTSD, loneliness, and depression. Astronauts living in space for long periods of time may benefit from prescribed doses of these fungi. One study showed how it enhanced the creative side in the brain, thus creating a feeling of belonging. And that is your psilocybin mushroom. And that is the end of my presentation. Short and sweet. Yes. Because we lived on a farm and we didn't have any neighbors. And so we wanted a hobby to do. Well, I can't really say because Marnie's here, but no, we actually ordered the spores from High Times because you could do that legally. This is like in 1979. But I just thought it's such an unusual food source. And I could see how it could totally be used in space. So, and then when I read all this research about it, and so that's that.
Okay, thank you, ma'am. So everybody's all refreshed. Tonight's talk is entitled NGC History in a Modern Revision by the NGC IC project. Sorry. Pleased to introduce Mr. Steve Gottlieb to our meeting tonight. Steve is perhaps the only amateur to have visually observed the entire NGC catalog, a project that took over 35 years and many trips to the Southern Hemisphere. He's a contributing editor to Sky and Telescope magazine and has written several dozen deep sky observing articles. His favorite deep sky objects are featured. Should have had this out. Hang on. This is a visual for everybody. This is the Deep Sky 600, okay, which he's contributed to the objects that are featured in that. No, you don't. You have to go buy your own. His website, Adventures in Deep Space, and I'm not going to read the URL here. If anybody wants to see it, they can look at this copy if they want to take a picture of it. Is a source of observing challenges for the advanced amateur. By the way, it's also in the newsletter, the page that advertises Mr. Gottlieb. And now please welcome Mr. Gottlieb.
Thank you. This is actually my second talk at this club. I spoke about 10 years back, and I believe I talked on about the discovery of spiral arms in M51 by Lord Ross at the time, and which is sort of historical, a major sort of historical realization or observation in astronomy. And this talk also is going to be about the history of visual astronomy. I've been an amateur, actually, you mentioned about 35 years. I've actually, working on that, observing the NGC, I've actually been an amateur, lived always in the Bay Area for probably over 45 years. And most of that time I've done research on the history of visual observing, which has been something I've always been very interested in. When I say the history, I mean generally the 18th and 19th century history of visual observing, when that was the main mode before photography and spectroscopy became, before the sort of science, modern science became the major focus of astronomy in the late 19th century. So I started off, like most amateurs, observing the Messier objects and some of the bright NGC objects from different sites in the Bay Area. Once or twice I was up at Mount Diablo, probably in the 1970s. Once or twice, a few times I was up on Mount Tam. Most of the time I was in the Sierras, though. I drove out to the Sierras, or I went down to Fremont Peak. And after a few years of observing, I sort of graduated, like most amateurs do, in telescope size, sort of got some aperture fever, and kind of started off with a 60mm refractor that was actually borrowed from my future father-in-law who had it stored in his garage to this was in the mid-70s, to a 6-inch Edmund telescope. I think that was in 77, to a C8. I think that was in 79, to a 13-inch telescope a couple of years later. And as I sort of, you might be under the assumption that the identifications of deep sky objects, when I say that, I mean clusters like the double cluster, the beehive cluster, and nebulae like the Orion Nebula or the Swan Nebula are well known, and they were discovered, we know, a long time ago, but there's no question about their identifications. But I discovered once you get beyond the brightest few hundred objects in the sky, well, that really isn't the case. You'll find all kinds of objects in the NGC catalog in which they've either never been observed before and their positions weren't verified, or different sources will give different opinions about their correct identifications. So we're still in the pre-computer age, and I started writing letters to professional astronomers asking for advice. Well, did they know what this object was that I observed down at Fremont Peak with my 13-inch? And I got in touch with a professional astronomer who was actually very well known for producing professional galaxy catalogs. His name is Harold Corwin. He worked at NASA or Caltech, and he and I sort of struck up a email, ongoing email discussion about the identifications of various objects. And that kind of grew into a major project to try to go back and reevaluate the correct identifications of all the objects that had been discovered in the 18th and 19th century. And that's really what the focus of the talk is going to be. What deep sky objects were discovered? You might say, well, that's simple. You just look at their positions. Well, that always will not give you an answer to what they discovered, because often their positions were extremely poor. So let's see. Do we want to? Got to make sure my pointer is working here. It was before. It went?
Yeah.
Let's see. Well, I'm looking at the presentation. The laser is working, but even my arrows are not, I mean, my right and left arrows. Okay. Yeah, let me, okay, here. Okay, maybe it's okay now. So the goal of the NGC IC project that came out of this email conversation with Harold Corwin was to re-examine the source material that was used to compile the NGC in 1888. The NGC, by the way, that you mentioned that I observed visually has 7,840 objects in it. And a lot of them are in the southern hemisphere. You can't observe them from our latitude. So to observe them, I did I have been to the Southern Hemisphere a dozen times to observe objects there. And there was a follow-up called the IC in 1895 that had about another 5,000 objects. That's my current project I've been working on. And we discovered that a large percentage of these objects, roughly 20%, had some identification problems. Positions were poor, so you couldn't tell exactly what objects, even when you processed their coordinates, they just landed on a blank section of sky. Or they were duplicates. Two different astronomers had observed the same object and assumed they were different, but that wasn't the case. All kinds of things from, in some cases, even the object, the position was okay, but the astronomer thought it was a nebula of some kind, or that's what they called anything that was nebulous, but typically it's a galaxy. It turns out that maybe the seeing was just poor, and it was actually a single or a double star. There's quite a few cases like that. So this, as I said, ended up expanding. Probably about 15 people got involved. These were some of the people that were involved in this project. As I mentioned, Harold Corwin, Wolfgang Steinecke is a German astronomy historian, and he has an excellent website where you can download spreadsheets of all the correct identifications. Brian Skiff's a professional at Lowell. Brent Arkinall's a professional at the USGS, and I'm down there at the bottom. So let me sort of discuss, I'm going to go through various early cataloging of deep sky objects. And Ptolemy's Almagest, actually, which was the model of the solar system that was used for 500 years, it had 1,000 stars. It was a stellar catalog, but it did include 7 nebulous stars. And it included, for example, M7, and which is a naked eye object in Scorpius, an open cluster, and the Coma star cluster. We're kind of advancing in years here. Al-Sufi's Book of the Fixed Stars, that was 964 AD. It's the first time that the Andromeda galaxy, M31, is mentioned as a little cloud lying before the mouth of the big fish. And if you look at the drawing here, you can, by the way, you know what the constellation the fish is? The Pisces, correct. So that fish is supposed to represent Pisces. And if you look sort of right to the right of the fish's mouth, you can see it looks like maybe something is ready to grab. And that A there, that little nebulous object, is actually M31, the Andromeda galaxy, which in days before light pollution was an easy naked eye object for most people. Nowadays, for those who live in the Bay Area, of course, that's not the case. This is an astronomer predating Messier called Giovanni Oderna, who lived in the 17th century. And little is kind of known about him. He's pretty obscure, but he, in actually 1984, a catalog that he compiled of deep sky objects, he observed with a small refractor, and his catalog showed 19 objects that he found with a small refractor. It was probably, I don't know, it could have been just an inch or something in diameter, or a couple of inches at most. but he discovered M6 in Scorpius, M36, 37, 38. Those are open clusters in Auriga. M41, another open cluster, Canis Major. Those are all actually open clusters, which are probably the easiest deep sky objects to discover because they have much higher surface brightness than galaxies. Though it is possible he discovered M33, the Triangulum galaxy. And as I said, 40 years ago, no one had, his work was completely, basically had been lost. Edmund Halley, which I'm sure everyone has heard of from Halley's Comet, he famously predicted the return in 1682, and it returned 76 years later. Little fact you probably know about the comet, but you may not know he was instrumental in the history of science, in my mind, by financing Isaac Newton's monumental Principia Mathematica, which was kind of the basis of his basis for calculus, all classical mechanics, universal gravitation, proved using calculus, Kepler's law in that work. So some people feel that that is probably the single most important work in the history of science, in fact. He publishes a paper in 1716 that lists 6 nebulous objects. They're slowly adding to the ones, the objects that we now know as Messier objects. M42's in there, M22, Omega Centauri. Halley himself is the discoverer of M13. Most people assume, I believe, I could be wrong, that Messier discovered the Messier objects, but that isn't true. He discovered some of them, not the majority of them, actually. Many of them were discovered by other people before Messier. Halley in 1714 discovered, for example, M13. M11 in Scutum, well, great open cluster, was discovered in 1681. Before Messier was born. This is a friend, colleague of Messier, Pierre Méchain, French astronomer, and he discovered in the Messier catalog 27 deep sky objects around 1780 from Paris, including a large number in the Virgo cluster and a number of, some of those are globular clusters that I listed at the end, M75, but there's some galaxies there. M79 is a globular. M97, I don't know, I don't have to go through these, but M97 is perhaps better known as the Owl Nebula. M104 he discovers that is better known as the Sombrero Galaxy in Virgo. He's the discoverer of that, not Messier. Nicolas Louis de Lacaille, he's made perhaps best known for naming several southern constellations while cataloging southern stars. And he took a journey to the Cape of Good Hope around 1750, and he discovered 26 deep sky objects using basically like a spyglass, a half-inch refractor at 8x. And some of the objects are famous that he discovered. Well, he discovered like the Jewel Box, for example, and the Tarantula Nebula. They're not Messier objects because they should be. They were known. He cataloged them before Messier, but again, I'm not sure everyone knows this, Messier only included objects in his catalog that he actually personally observed. And he never went to the Southern Hemisphere to observe these showpieces. So he never saw, for example, 47 Tucani, which is the best, perhaps one of the two best globulars in the sky, next to, along with Omega Centauri. I'm afraid for fans of like M13, that's kind of down the list in the best globulars in the sky if you haven't been to the Southern Hemisphere. So here I've been talking about Messier. He catalogs 103 objects in 1781, and he discovered roughly a third of them, 36 objects, using a 3-inch refractor and a 7. We're not sure exactly what telescopes he used for which objects, but 3-inch refractor, 7-inch reflector. This is sort of his description of M1, the supernova remnant in Taurus, the first object in his list, nebula above the southern horn of Taurus. It doesn't contain any stars. It is a whitish light, elongated in the shape of the flame of a candle, discovered while observing the comet of 1758. So he was discovering a comet, finds this nebula that doesn't move, so it's not a comet. It's obviously not a planet. It's nebulous. And he decides to produce a catalog of all nebulous objects in the sky so that other comet seekers, that was the game then, not observing M1, but discovering comets, so that other comet observers would not be confused would get M1, for example, or some other object confused with a comet. And there were some objects added later after his first catalog, M104 to M110. I'm not sure everyone knows this either, there were 4 Messier objects that were initially, we could say, lost. In other words, his positions pointed to a blank point in the sky. One of them was M47, that's an open cluster in Puppis, and he just reversed a plus minus sign, basically. But once you apply the right sign, how far offset means how many degrees it was away from the star to Puppis. Once you change the sign, so instead of plus, make it minus, it leads right to M47. M48, he just either made a transcription error or some kind of error for the declination in M48, and that he was off by 5 degrees, but his right ascension was correct. M91, there was nothing is at his position for M91. That's a galaxy in Coma Berenices, and he described it in reference to another Messier galaxy, but he got confused and referred to the wrong galaxy to find M91. And once that's corrected, M91 was identified. There's still one object that's really, you could still argue about, and that's M102. It might be a duplicate observation of M101, though sometimes in Messier marathons, I don't know if people here have done a Messier marathon, some people take, usually you take the galaxy NGC 5866 as a, to stand in for M102, or assume that's M102. The greatest visual observer of all time is, without a doubt, William Herschel, who becomes famous for discovering, for first person to discover a non-naked eye planet, discovers Uranus in 1781. That's the same year the Messier catalog was published. And he wanted to become familiar with the sky. There's books written about Herschel. He didn't start off trying to discover nebulae. He started off basically observing, just becoming familiar with the sky and observing bright stars. At the same time, his sister, Carolyn, had a little small comet seeker that he built for her, and she would sweep for comets while he was going through the process of observing and becoming familiar with the sky. And she started discovering some deep sky objects with her little comet sweeper. And he realized, well, wait a second, maybe there's more nebulae in the sky to be discovered than what Messier has listed, his 103 objects. He starts sweeping for nebulae a couple of years later. And by 1786, just in 3 years, discovers 1,000 new objects. Of course, he had a much larger telescope that he built than anyone else had at the time. And in 1789, 3 years later, adds another 1,000 objects. These aren't known objects that he's looking up. He's discovering all these by doing nightly sweeps. And in 1802, his final catalog has 500 objects. So he discovers 2,500 objects and increases the number of objects that are known. These are, when I say deep sky objects, I'm including open clusters, globular clusters, emission nebula, reflection nebula, galaxies. Those are the principal classes. Increases it from 100 to 2,500. But he did make some mistakes, even though he was a very careful observer, and Carolyn took excellent notes for him. This is his telescope. It's an 18.7-inch Newtonian with a metal speculum mirror, which is a copper tin alloy, observing from England. And he also kind of took a scientific approach and just didn't describe everything as a fuzzy blob. He tried to put things into classes, and he had 8 main classes: bright nebulae, faint nebulae. These sound, I know, kind of silly, but he wanted to at least classify certain objects just on their brightness. So bright, faint, very faint. He had a class called planetary that did include planetaries, but it also included other oddball objects. Very large nebulae, that would be like large emission objects, emission nebulae, like something like the Lagoon Nebula, or
They go up and down, or scaffolding like been in a circle?
Well, no, it was designed. Good question. It was designed to rotate, and if you look at the bottom, you can kind of see he had wheels. But he discovered very shortly that that was a very inefficient way to observe, moving it around to different portions of the sky. So he set up the telescope never moved it. Well, he moved it a couple of degrees, but he set the telescope up due south, okay? And never moved it, and let the sky pass in front of him. And all he did was, well, he had a worker move the telescope. There was pulleys pulling it up and down, and he had a rope which had increments on it that he knew how many degrees it was moved up and down, etc. So he did, so by basically, as the sky moved across the, across from east to west. He's just moving the telescope, sweeping up and down several degrees. And as he goes up and down, new objects pass through his field of view. If he doesn't catch it on the way down, he might catch the object on the way back up. And he just went up and down and up and down. Then after a while, he may have moved the telescope to a completely different elevation, lower or higher, because he only used, I forget how many degrees, but let's just say it was 5 degrees. He just, I don't know if you know anyone else better, about 6, something like that. Yeah, 6 degrees up and down. He just moved it. And so sometimes he had to move it vertically, but never horizontally. And he standardized descriptions that were used for the next 100 years anyways by visual observers that actually, I don't know if you can read that, the PB, I'll read it, I'll translate it. It stands for pretty bright, PB, L large, the LE is little elongated or extended, and the GMBM, capital M, is, I'm sure you would not guess it unless you're familiar with his shorthand, stands for gradually much brighter in the middle. Okay. And that's the way they appear in his catalog. Now, this actually is a page from his collected works that was actually published. This is not his original, a page from his original catalog, but this was reprinted and edited by Dreyer, who I'll talk about later. And but this is what it looks like. And his son, famous astronomer and scientist, John Herschel, he continued his work. His father felt like his work was unfinished because he'd only cataloged the objects visible from England, which is over 50 degrees latitude. And he brought, that is, remember the telescope I showed? The 18.7 inch. Well, I wrote here his father's, but it was actually completely rebuilt. It wasn't the original 18.7 inch reflector, but I believe it was probably one of his father's mirrors or a couple of his mirrors that he took to South Africa. And he discovered nearly 1,900 objects in the Southern Hemisphere. And then in 1863, we now get the first sort of really large catalog that includes all the Herschels, both father and son, called the General Catalog in 1863. You could abbreviate that as the GC, and there's 5,000 objects. Father and son discovered the vast majority of them between William Herschel's 2,500, just add them together, 2,500 for the father, 1,900 for the son. That's 4,400 out of the 5,000 objects. And here's that telescope. This is actually a woodcut done in Cape Town, South Africa, where he discovered the Southern Nebulae. That was not the largest by far, the largest telescope. Bigger ones were to come in the 19th century. William Parsons, the third Earl of Ross in Ireland, he is an engineer and is used to big projects and lived on the Burcastle estate in Ireland. He starts off, his first telescope he builds, or he may have ground some small mirrors, made a few small telescopes, but he builds a 36-inch telescope. And after that, he's convinced of his methods that he's able to construct a large telescope. He builds a 72-inch speculum reflector. This was the subject of my previous talk. And he discovers spiral structure in M51 with that large telescope and many other galaxies. That's on the left, lower left, that's actually his sketch of M51 in comparison to a very poor photography, an image taken by an astrophotographer of M51. But it's sort of blurred out somewhat to give a comparable view. He does discover 224 objects in the NGC and 7 more in the IC. That's what that telescope looks like. You can see the ladder going up, and they did have a viewing gallery up there. You can see someone at the eyepiece up there. And once again, it was fixed in position, pointing south. And you can see between the 2 walls there, and the telescope was just raised by a crank. And his observations were published in 1878. He observed the spiral structure in M51. This was built in the late 1840s, but the catalog came out in 1878. I do have a copy of his catalog. This is what the catalog looks like. And those little drawings there, they're actually nebulae that he made or the observers at Burke Castle made little sketches of the nebula that he discovered. Here's an amateur or American astronomer, probably in terms of discovering objects, the greatest one, Lewis Swift. He discovers the 12 comets, including Swift-Tuttle, the parent of the Perseids. And he discovers 560 NGC objects and another 585 IC objects, which the second group, he started observing at age 75, which is, to me, pretty amazing. And he had no formal university training. Here's a quote, though, he made. He originally observed from Rochester, New York, but in 1892, we complain about light pollution, but his quote was, "The large and increasing number of electric street lights of this city has rendered the search for faint bodies almost useless." You'd think that was written today, and may compel me to entirely abandon their quest and enter upon some other line of work. Well, just like we might go out, just like we might not want to observe in the city and therefore bring our telescopes, we'll drive them out to some dark sky location, he does the same thing. He takes his 16-inch Clark refractor, very large telescope for the day, and moves it to Southern California, actually near Mount Wilson, to an observatory that was built there called Low Observatory in 1895 on Echo Mountain. That telescope, believe it or not, ended up, well, the observatory was kind of destroyed in a storm. There was also a fire there at one point, but the telescope was in storage and finally purchased by Santa Clara University. And that's me and a friend, Jimmy Lowry, at Santa Clara University at the telescope. It's been restored largely. Not some of the parts original, some of the parts obviously, and some of the parts are not original. But in any case, that telescope, you can't really observe with that telescope, at least currently the university. There was, the dome leaked and they were afraid equipment inside was going to get ruined. So the university actually sealed the dome. And right now there's no nighttime observing, like in some places, some of the old classical telescopes, of course, like the Lick 36-inch is still operational. Another observer, William Lassell, built a great telescope, as you'll see. He first builds a 24-inch equatorial telescope that he discovers the Neptune's brightest moon, Triton, in 1846, and Saturn's, I don't know, maybe the seventh moon or eighth moon, Hyperion, in 1848. And he builds a 48-inch, not a stationary telescope like Lord Rosse does, but he builds an equatorial reflector that he actually transports to the island of Malta. And he has an observer who discovers 600 objects. This is what that telescope looks like. And you can see the observer up there at the kind of on a stand up there that was movable. Pretty amazing. Fork-mounted equatorial. Of course, they had no electricity. The drive was literally done by an assistant turning a crank at 1 revolution per second. This is Stefan, who's perhaps Eduard Stefan was perhaps most famous for Stefan's Quintet, which is a popular amateur challenge list. He discovers over 450 NGC objects with this telescope. It's a beautiful 31.5-inch reflector on another fork, equatorial fork, with still, and he discovers, oh, I don't know, I don't know if I put in the number he discovers, but he discovers quite a few number of objects. There was a large observatory that in the US that was responsible for a number of discoveries. One is the one observatory is in Virginia called Leander McCormick, and they had a 26-inch refractor right there. And that's been, I think, restored. They had very poor positions that were often off by a half a degree to 1 degree. And a lot of their discoveries were considered lost. No one knew where they were. And someone on the team searched in the observatory library and actually found notebooks with sketches. And using those sketches, our NGC project was able to find the objects that were discovered. I think I'm going to skip B. Gordon, but he was a French observer who I'm very impressed with because he produced very precise positions of 6,600 nebulae using a 12-inch refractor. He was just an amazing visual observer and publishes the last great visual survey, literally, in 1919, with, after that, of course, there was no visual observing, was over by that. The era of visual observing was over before then, and produces 20,000 accurate positions measured personally. Here's Dreyer. He's a Danish astronomer who compiles the NGC, and he has to take everybody's observations with all these different apertures, telescopes, observers. Some positions are accurate, some of them are very imprecise. And in 1 year, he's able to produce the NGC catalog in 1888. And he did have some help. There was a German astronomer, Darest, who was able to sort of confirm the positions of a lot of objects, but a lot of the objects still were not confirmed by anybody else other than the original observer. And up to 15, maybe even 20%, we've discovered had some kind of identification issues, or as I mentioned in the first slide. This is what the NGC looks like. That's the first page, NGC. It's just a table with numbers, who discovered them. There's a column that says other observers. The right ascension, declination is there. And if you look on the right side, you may not be able to see it, but those are all the descriptions following the Herschel code. That the very first one says FSR, faint, small, round. I can read all these just like I'm reading English here. I'm just picking another one, NGC 18, to the right, it says faint, very small, irregularly round, much brighter in the middle. Some other object, H4, precedes, it says P, but that means precedes or west by 19, I think that's seconds.
What was the second to the bottom one?
Yeah, the second to the bottom one. Well, you mean the description?
Yeah.
It says F, which is faint, that's all. And then in parentheses, it says AUW1. That was a catalog by another astronomer called, whose last name was Hours, AUWERS. It must have been the first object in his catalog. I don't know why he put that down, but that's all that was. So what can modern research reveal? Well, if we go back to the original source material in the NGC, we can find the original visual descriptions that are not found in that NGC, along with sketches. And sometimes we can correct the positions and compare the visual descriptions they gave with modern images and data. And I observed them all with an 18-inch as sort of a check to see whether with a certain size telescope, how easy they would have been visible. And we've discovered that, and we have actually solved nearly all identification problems of those 20%. Now, we're talking about almost 7,800 objects. So 20%, we're talking up to 1/5 of those objects. So we're talking more than 1,600 objects or so. So let me give you some examples, okay? Here's a galaxy, NGC 575 in Pisces. So there's nothing in the position of the NGC. If you look in the NGC, the original NGC for 575, look up the position, process it to 2000, take a look at a print or any kind of image of the sky, you'll find nothing there. But we went back to the original catalog or the original discoverer's notes, and Dreyer made a transcription error of 2 degrees. He just copied it wrong by 2 degrees. And so it's wrong in the NGC, the position. That's why there's nothing there. But then, because there was nothing at that position, another astronomer in 1896 rediscovers it and we're at the correct position, 2 degrees off, and it has a new designation in the IC catalog, the index catalog that followed the NGC, and it became known as IC 1710. And no one knew where NGC 575 was. But even though the galaxy was formerly called IC 1710, it's now correctly known as the correct identity, NGC 575, has been restored to that galaxy by our project. And this would be true by amateurs in atlases they use or catalogs they use, but also professionals. This is another famous case. You may or may not have heard of this group of galaxies called Copeland's septet, but it's 7 galaxies, septet, discovered by an astronomer called whose name is Ralph Copeland, and he discovered it with Lord Ross's 72-inch. But there was again an error in the NGC. The position is wrong, and there was a modern version of the NGC called the RNGC, and that stands for Revised New General Catalog. It was an attempt to make a modern version with photographic descriptions as well as the original visual description, and they call this entire group non-existent. In other words, there are no galaxies where they were supposed to be. But of course, that was just a mistake. It was a wrong position in the NGC. And once we corrected the position, they all match up with those galaxies. Now, if you actually count them, you may see 1, 2, 3, 4, 5, 6, 7, 8. I think I see 9 galaxies there. There's also there's obviously a lot of stars there, but there was only 7 that were actually discovered visually. That's why it's called a septet. This was not discovered on a photograph like the one I'm showing you. Copeland septet? It was corrected in the 1990s. They're pretty faint. They're the brightest might be 14 down to 15, maybe even 16th magnitude. They were discovered with a 72-inch. I'd say the faintest are 16th, at least 16th magnitude.
That impacts more than something that the new telescopes look at, because it's just like, look at all the possibilities of those little galaxies.
Yeah, and look how close together they are. They're actually it's a physical group. So here's an interesting case. Hopefully you can see that I have 3 galaxies in this image, kind of in a row vertically, labeled as IC 4614, IC 4615, and IC 4616. Those were the known designations for those 3 galaxies. Well, there's 3 NGC numbers that if you look at the circles, you can see that they just fall on a blank. There's nothing there. And so they were just lost. I use lost meaning no one knew where they were. Okay, but when we went back and looked at the original notes, we were able to find that all 3 of them were offset from the correct positions by a certain amount in right ascension and declination. And once we make the correction, that NGC 6199, surprisingly, does not land on one of those galaxies, but it actually lands on a faint star that the arrow is pointing to. But 6197, once we make the exact same correction, points right to IC 4614, and 6196 points right to IC 4615. Now, that leaves one galaxy without an NGC number. Well, the discoverer, I forget if it's Herschel or who was the astronomer who discovered the NGC galaxies, but they missed the top one. And if you look at the image, it's a little bit dimmer than the other one. So it was just a little bit beyond their grasp, and it just wasn't found. So now the top galaxy is still known as IC 4614, but the one in the middle is now known as NGC 6196. Like if you look up the galaxy on Sky Safari, you would look up NGC 6196, or if you looked up on a star atlas, a sky atlas of one of the popular sky atlases, you'd look up 6196, and the bottom one is 6197.
Can you go back to that?
Yeah.
So this is discovered more recently.
Oh, this is all with the group of astronomers that I worked with. Yeah. Yes, exactly. This is what we discovered, this realignment, correct. I'm trying to come up with, we discovered hundreds of errors like this. I'm trying to give sort of representative examples. Well, that I see the top one wasn't the one that doesn't have an arrow pointing to it, was discovered later and wasn't one of the NGCs. That's what I was saying. It just was, it was missed. So that is the correct identification. One of them has the correct identification. Two of them had later identifications that have been corrected to reflect the correct historical record. So this is an interesting case. There's two galaxies here, but there are 8 IC numbers, 4 on the top, 4 on the bottom. How in the world did this happen? Well, do you remember Lewis Swift I mentioned, who moved to Southern California when he was 75 and continued observing objects? Well, sort of age kind of caught up with him a little bit in terms of memory. And at 2 years after he had moved to Southern California at the age of 77, he discovered these 2 galaxies in the same summer, I think within a 2-month period, 4 times, and assumes each time assumes it's a new object. He rediscovers them and can't remember that he discovered them 2 weeks earlier, and records them as new, but not only that, records them at slightly different yet incorrect positions. So all 4 of them are at wrong positions, but they clearly all refer to the same galaxy. How do we know? Because if you compare the separations between the 2 galaxies in terms of how far apart they are in declination and right ascension, they're all identical, but they're all at different positions. Okay, so this top galaxy happens to have 4 IC designations. The bottom one has 4. Okay, this is an article I'm working on for Sky and Telescope this minute, actually. I have to submit it next week. It's going to be published in the spring. You may or may not know this. I don't believe I believe this is pretty obscure, but before Lowell was not the first person to initiate a search for, you want to call it Planet X, or I call it a trans-Neptunian planet. He was not the first. There had been a photographic search earlier by the director of the Harvard College Observatory. But even before that, in 1878, there was a brief visual search for a planet soon after Uranus was discovered. Soon after Uranus was discovered, some astronomers using mathematics predicted that based on the perturbations in the orbit of Uranus and the predicted orbit of Uranus, it was being pulled a little bit by another external planet. And David Todd, using the 26-inch, I believe, refractor at the US Naval Observatory, did a visual search. And while he was doing this visual search in 1878, he discovered a number of deep sky objects. One of them is IC 591. Problem is, he gave very poor or non-existent positions. So here's his little diagram that he published. You see A and B in that little panel? That was his diagram of the nebula. Or he thought it could be a planet, and then he went back a few nights later to see if it moved. It hadn't moved. He knew it wasn't a planet. In any case, no one knew what that B was, like what galaxy that was. But because no one had looked at his diagram or his sketch. But if you look at, now compare, this is the same strip of sky. The galaxy, the oval that I have circled is B on his diagram. That's IC 591. There's 2 stars that he has to the lower right. I circled those 2 stars. There's 3 stars making kind of a right triangle with A at the vertex of the right triangle on the left, on the left side. And I've circled those 3 stars, and those are the stars. They match up perfectly. They match the picture exactly. And so we discovered that that was the galaxy That is IC 591. Again, this is just one of many, many, many examples. Okay, here's another example. I just have a couple more. This is another example with two NGC objects, numbers 2363, 2366, but it seems like there's three objects that I've circled here. And it was assumed that the one that I've labeled 2363 is the sort of the bright red one, and the large oval is 2366. But if you actually read William Herschel's original description of 2366, he described it as very faint and small. Well, the big oval doesn't look small. And then he said it showed a very faint branch to the northeast. Northeast is upper right. Well, that big oval then to the upper right, that's kind of tilted, that's the faint branch. And the very small object, the very faint and small, must be the one that I circled as 2363. And as far as 2363, that was discovered by Lord Rosse, and he described it as a diffuse nebulosity to the west. West is to the right, a distance of 1.2 arc minutes. Well, the one that's if you measure it on the sky, the one that's 1.2 arc minutes to the right is that third oval on the right that I discovered, that I circled. So the correct identifications are the right one is 2363, not the one that had been assumed to be 2363. And 2366 is not the big oval on the upper left, but the small bright one next to 2363. So that's again, that's just kind of an interesting case. This last one, I think this is the last example I have. IC 2120, it was assumed to be this little nebula with a star in the center in Auriga. It's off 40 arc minutes, which is more than the size of the full moon from the position, but it's the only thing around in the sky. So it was assumed that that was IC 2120. Well, we went into his log book and made an amazing, surprising discovery. On the night he discovered IC 2120, he observed a comet. Okay, on December 8th, 1890. He took notes on this comet. Comet's not in the picture here. He observes a comet. Then he decides an hour and a half later to go back, take another look, and re-observes it. Okay, no problem. He observes the comet twice. But apparently, he apparently did not record in his logbook that the second observation referred to a comet. He just records that he observed it and described it. So later on, he reports the second observation as a new nebula. He forgot that it was the second observation of the comet that he observed earlier in the evening. And we went back and measured the position of the comet at the time he recorded the second position. It's within 1 arc second of where the comet was, which is just a tiny, tiny amount. So there's no doubt at all that IC 2120 is actually a comet. It's not a deep sky object at all. You'll never be able to observe it unless you observe that comet right there. Okay, so is what we're doing worthwhile? Well, the NGC and IC designations are still the most commonly used identifications or designations by professionals and amateurs. And it's important also because unambiguous identifications are necessary to avoid confusion, to give proper historical attribution, discovery attribution, which is an essential thread to maintain the integrity of astronomical history, still continue today with comets, where we name the comet. If it's a person who discovers it, which of course happens less and less. And it's appealing to me. I like the idea of this chain of astronomical history from the earliest visual observers who first looked at the heavens, had no idea what they were looking at, if these objects were near or far away, no idea what galaxies, the Milky Way, what it was, anything. They were just struggling to make sense of the mysteries of the universe. And this last page, this is actually, I think, the mention was made of my website. This is sort of the home page of adventures in deep space. You can Google adventures in deep space. If you don't have to write it down, I think you could also, if you have my name from the newsletter or whatever, someone did a Wikipedia page on me, so you can look there. I know the website's there also. And on this page, I do have inside that box on the right, it may be very hard to read that, but inside that box, it says Steve Gottlieb's NGC notes, and I have notes there of all 7,840 objects. It's the only record anywhere modern record of all of visual observations of the entire NGC, as well as a few thousand IC objects also. So I think that's it.
Thank you very much, Steve. Appreciate it. Anybody? Oh, there's a question back here. I don't think any chat came up, so I'll go back here and get the moon.
I probably don't need it. Well,
Nobody else in-
so you have observed and made corrections.
I've observed all the galaxies. When I say observe them, I mean through a telescope, visually with my eyes, all of them individually, but I've also, the team, it was a team effort. We also went back into the historical logbooks, catalogs, etc. We didn't rely on the NGC. We went back to the original historical records, often that are kept in, for example, the ones with Lord Ross are kept actually at the castle, the actual logbooks, etc. Members of the team actually investigated all the original records to make sure to confirm what was actually seen.
It's not really a question, but because of looking at those original archival pages, I just think it would be cool if what you did was on paper too, but I know it's not.
Yes.
Just because I love that old,
Well, I do have my observations online,
of course.
and I am working. This hasn't quite started yet. It's in the formation process, but a group of individuals are working together to produce an NGC update, if you will, that will include images of every object in the NGC, as well as modern information and highlights certain objects that have identification issues, and that will use some of my work as well as other people's.
So where there has been an error, have you noted it and,
Yeah,
have you
so-
shown the old, formula versus what you discovered to be the new? I mean,
That's
call it
all, and all of that information actually is in my notes that are online. I have a visual description that's sometimes several paragraphs, and below it I have a little historical discussion of the object for all 7,840
And
objects.
what would you like on your headstone? Just kidding.
But
That's a
you
lot of
can-
work.
If you just want the data itself, you can get it from Wolfgang Steineke's website. He has Excel spreadsheets of different catalogs. Yes.
I'm assuming that catalog apps that have like Starry Night Pro.
Oh, yeah.
or-
So a lot of the, yes, a lot of the amateur software, first of all, our work went into, first of all, the identifications that are used, for example, as far as paper charts, like the uranometria star atlas, for example, not ones that were around, of course, before our project began, but the uranometria would be like an example. But it's been incorporated into there's a couple of exceptions, but most software, if you look, for example, so if you look, you'll often see, it'll say NGC, IC data from Wolfgang Steineke, or someone NGC, IC project. So most of it has been, most amateur software does incorporate the corrected NGC that came out of this project. Yeah, all the go-to, for example, well, not only that, I did the databases for several of the go-tos going back quite a ways, like the current Nexus, earlier versions of go-to telescopes. I did the database, the NGC database, with the corrections that were in devices that Lumicon sold back in the 90s and 2000s, that decade, and as well as Celestron and some other ones. They paid me to provide a database with all the corrections in it. So yeah, I was involved in producing those databases that you might have in a go-to telescope. Yeah,
let's see, I can get to you easier. Hang on a second.
Steve, do you guys use data from the Gaia Deep Sky survey? I know that's for stars, but for offsets and stuff,
for
determining the correct positions of these.
Oh, yeah. I think most of the positions were, I believe, whenever possible, computed by using SDSS positions, which were available before Gaia. And of course, they don't have quite the same accuracy, but they're very precise, much more precise than amateurs need. So the positions I even have online in my database or in amateur software, they all fall close to the center of the objects. But no, to answer your question, they haven't been corrected to, all those decimal places that Gaia might have. Yeah, next question.
Is the NGC and the IC, are they completely separate catalogs
Okay,
or
so
they
the
overlap?
Yeah, so the NGC, they were both compiled by the same Danish astronomer, Dreyer. He did one the NGC came out in 1888. Subsequent to 1888, this still was visual astronomy for the next decade was still very common, even though photography was starting to take over. And lots more objects were being discovered. NGC was completely visual. Up to 1888, everything was visual. In the next decade, it was probably half visual, half photography. And then after that, it was mostly photography. But he started getting more and more discoveries that were, mailed to him. And he just decided after it got up to several thousand, like, oh, I need like an appendix, essentially, like an addendum. So the index catalog is like an addendum, and there was actually two of them. that he produced, both of them. One's called, we call them the IC or index catalog, but there was an IC1 and an IC2. They both have in total about 5,000 objects, and they're completely separate. They should be all new objects, but as you saw on that very, very first one I gave, the very first slide I gave of an error, it was known by an IC number because the NGC number gave a wrong position, and it was rediscovered later and assumed to be new. So it also has an IC number. And there's quite a few objects like that.
Is the IC static at this point? And
Yes.
it
Oh,
only,
yes,
everything's
the-
only going
the
into
last one
NGC.
was the IC, the second index catalog was published, I think, in 1908, and that's it. Now, after that, there was lots more photographic discovery, thousands and thousands, until it became, the Palomar Sky Survey, the numbers
Thank you.
became into the 100,000s and millions. So, yeah.
Oh, thank you very much. Just a quick reminder, the name of the gentleman that founded the Low Observatory again?
Oh.
L-O-W-E? No, Lowell, L-O-W-E?
Oh, Lowe. Yeah.
Yeah.
That was Lewis Swift.
Lewis Swift, thank you.
Yeah, Lewis Swift, and he was as I mentioned, he was an amateur, did not have university training, basically got into astronomy to make some money discovering comets, because there was actually at that time a prize for discovering a comet, and you could get a couple $100 for discovering a comet, which was a ton of money in those days.
Sure.
And that's what he did. And while then as he was searching for comets, he started discovering lots of nebulae, galaxies. And then he's the one who eventually moved to Southern California for darker skies, complaining about electric lights in the 1890s.
That's no longer.
No, it's no longer, it's gone.
Okay, well, I think we have to wrap this up today.
Okay,
But hang on, before you get too carried away there, so hang on. Let's see if we got a chat going here. Yeah, I know there was one question that popped up and, well, maybe not. Okay, not a question. Oh, come on. Let's go. Oh,
Thank
that was it. Okay, all right. Thank you very much. Appreciate it.
welcome.
Oh, okay, thank you. Hi,
Oh.
I don't want to forget your.
Oh, well, thank you very much.
You should write something in it, but I didn't have time.
No problem. That's okay. Pardon? Yeah, what about Messier?
He was looking for comets.
Yes, he was.
He cataloged stuff that weren't comets.
Correct.
Went to find them again. Did he ever,
But he's
Credits for any
more,
comets?
oh, yeah, he discovered comets. Yes, he did.
is there a
Uh,
record of that?